This is a video on statistical inference for a difference in means. I'm doing problem 25 out of chapter 24 of your book. So, in June 2002, the Journal of Applied Psychology reported on a study that examined whether the content of TV shows influenced the ability of viewers to recall brand names of items featured in the commercials. The researchers randomly assigned volunteers to watch one of 3 programs, each containing the same 9 commercials. One of the programs had violent content, another sexual content, and the third neutral content. So does the content of the commercials affect does the content of the program affect their ability to recall the names of the companies in the commercials? The researchers contacted the subjects 24 hours later and asked them to recall the brands advertised. Here are the results: the number of subjects for each one, and the mean number of brands recalled and the standard deviation of the brands recalled. Is there a significant difference in viewers' abilities to recall brands advertised in shows with violent and neutral content? So we're going to look at violent versus neutral. Is there a significant difference in their ability to recall brands advertised in shows with violent content versus neutral content? So this is a difference in means. We're going to run, if we want to know if there's a significant difference, we're going to run a hypothesis test. What kind of hypothesis test will we run? Well, a 2-sample t-test for that difference in means. Because we have 2 samples, the sample that watched the violent content and the sample that watched the neutral content. So our null hypothesis is a statement about those 2 means. The mean of those who watch the violent shows versus the mean of those who watch the neutral shows. And the null hypothesis is that they are the same, because we want to know if there's evidence that they're not the same. So that has to be our alternative hypothesis. The fact that they are the same would be the null hypothesis, so that we can tell if we have evidence for the alternative, which would be that the mean of those who watch violent shows is not the same as the mean of those who watch neutral shows. So what you want to find evidence for is always what you make your alternative hypothesis. So we need to define what these symbols represent, because we can't just use symbols without defining them. Mu sub v is what I'm calling the mean number of brands recalled for viewers of violent content. And then obviously mu sub n is the mean number of brands recalled for viewers of neutral content. So I need to state what those sample means are. So y bar sub v is 3.02, and y bar sub n, the sample mean for those who watch neutral content, is 4.65. So this is a test for the difference in means, so I should find the difference in those sample means. Y bar sub v minus y bar sub n is 3.02 minus 4.65, or negative 1.63. We want to know if that difference is significant enough to say that there is a difference between the number of brands they can recall if they watch neutral versus violent content. We'll do this significance test with alpha equal to 0.05. But before we proceed, what do we need to do? Right, we need to check the conditions. So, conditions. First, it's stated in the problem that the researchers randomly assign the volunteers. So, the subjects were randomly assigned. Notice I'm not just writing the word random. I'm stating how the randomness was used. They were randomly assigned. Check. Alright, our second condition is normally the 10% condition. Well, what that is really testing is independence, and what we need to do with 2 samples is indicate that these 2 samples are independent of each other. So the recall of one group should not affect the recall of the other group. So they should be independent. Third condition, approximately normal. Well, our sample sizes are 101 and 103, so the samples are large enough to assume approximately normal. All right. Now we're ready to proceed with the test. The test statistic, our t-value, is that difference in the sample means, negative 1.63, minus the hypothesized difference, which is 0, over the square root of 1.61 squared over 101 plus 1.62 squared over 103. That's the sample standard deviation squared over n1 plus the second sample standard deviation squared over n2 added together all underneath the square root. Obviously, you don't need to do that if you're going to do it on your calculator. That's how you would calculate the test statistic by hand. And that test statistic is approximately negative 1.63 over 0.226, which is approximately negative 7.21. So remember, the test statistic is your statistic, which is our difference in sample means here, minus the null hypothesized parameter, which is 0, because we said that those two means would be the same in our null hypothesis, so when we subtract them we would get 0, divided by the standard error, which is the square root of s1 squared over n1 plus s2 squared over n2. So negative 7.21. Our p-value then is the probability that t is less than or equal to negative 7.21, which is approximately 1.1 times 10 to the negative 11th. Pretty small. Now, if you did this test in your calculator, you would get very similar values for the t-statistic and the p-value. And the degrees of freedom that the calculator tells me is 201.96. In order to get that exact of a degrees of freedom, you have to use your calculator. Otherwise, you can approximate it by doing the smaller of the n minus 1s. So n1 minus 1 is 100, n2 minus 1 is 102. You would use a degrees of freedom of 100, which would lead to significant differences from using a degrees of freedom of 201.96. That's why we use the calculator, because it gives us a better degrees of freedom, which gives us a better p-value. So our p-value of 1.1 times 10 to the negative 11th, I think that's less than 0.05, so we reject H naught. We reject the null hypothesis. When we reject the null hypothesis, what does that mean? Well, we have convincing evidence that the mean number of brand names recalled is different for viewers of violent content and viewers of neutral content. And in fact, since our sample mean was a negative number, when we subtracted violent content minus neutral content, that means we have convincing evidence that the mean number of brand names recalled is actually higher if you watch neutral content rather than violent content. So that was a two-sample t-test. What about performing a confidence interval? Let's find a 95% confidence interval for the difference in mean number of brand names remembered between the groups watching shows with sexual content and those watching neutral shows. So we did violent versus neutral. Now let's do sexual versus neutral, but let's choose a confidence interval approach rather than a hypothesis test approach, just so we can see how that works. And then, of course, we will interpret our interval in the context of the problem. So what kind of interval is this? Well, we are comparing to each other, so it's a two-sample t-interval for that difference in means. Now, the conditions for a two-sample t-interval are the same as the conditions for a two-sample t-test, and even changing from violent content to sexual content, our conditions are still met, so we will just note that the conditions were checked and verified in Part A. So we don't need to check them again. we're comparing the sample mean for neutral content, which is 4.65. That's the mean recalled by neutral content viewers in the sample. And we're comparing that with the mean recalled by sexual content viewers, which is 2.72. So notice how I defined what each of those numbers and their symbols are representing. We're interested in the difference in those means. So y bar n minus y bar s, which is 1.93. There's a standard deviation for n of 1.62, and the sample size for n was 103. There's a standard deviation for s of 1.85. The sample size for s is 106. I'm just copying those from the table. When I do this on my calculator, which is what I'm going to do here, because it gives me the more accurate degrees of freedom of 204.8, my confidence interval is 1.456 to 2.404. So I'm going to interpret that. How do I interpret a confidence interval? Well, you know how to do it. We're 95% confident that the mean number of brands we call 24 hours later is between 1.456 and 2.404, higher for viewers of shows with neutral content than for viewers of shows with sexual content. So notice the way I chose to interpret that here, rather than just saying that the mean difference was between 1.456 brands and 2.404 brands. I added a little flavor to it by saying, well, if that difference is a positive number like this, then that means it's actually higher for the neutral content rather than the sexual content, because I subtracted neutral minus sexual to get the sample mean. If I subtracted in the other direction, I would end up with negative numbers, and that would still indicate that the neutral was higher than the sexual one. Make sense? Good.